Kirkwood Math. Welcome, ladies and gentlemen, to another lesson of Kirkwood Math. Here we are at 1.7. That's right, you heard it correct. We are jumping back to topic 1 to take a look at something that we didn't cover before. The reason why is because it's going to relate to the things we're learning in topic 5, which is piecewise functions. So we're going to kind of take a minute and re-understand about absolute value and take a look at absolute value equations. We are on page 28 and 29 in your student companion, so please turn to those pages and get ready. All right, so we're going to take a look and remind ourselves really quickly what absolute value means, okay? So we're going to take a look at the study tip here. I would write this down in your notes. Remind yourself that the absolute value of a number is its distance from 0 on a number line. So that means that if you are trying to find the absolute value of 5, 5 is 5 hops away from 0 on a number line. And now we're going to see what that means when we have it in an equation. So we want to know what the value of x is in the equation 7 equals the absolute value of x plus 2. So first we're just going to treat it like a regular old equation. Just pretend that that x is just a regular x, okay? Use the subtraction property of equality to subtract 2 from both sides, isolating x, in this case the absolute value of x, all by itself. So now we have an answer. The absolute value of x is 5. What are we going to do with that information? Well, we're going to take a look at the meaning of absolute value and we're going to apply it to what we just learned. If the absolute value of our number is 5, that means that I have 2 possible answers. My solution, x, could be negative 5, because negative 5 is 5 units away from 0, or hops. Or my answer could be positive 5, which is 5 units away from 0, or hops. Therefore, I have 2 solutions. Both negative 5 and positive 5 work for this equation. In other words, I have 2 inputs that will get me the same output in this equation. Next, we're just going to check those solutions to really make sure, can this be true? And yes, sir, it can. So we're going to go ahead and plug in negative 5 in my equation and positive 5. The absolute value of negative 5 is positive 5 because it's 5 hops away from 0. Add that to 2 and I get 7. Over here, same thing. Absolute value of positive 5 is positive 5. Add that to 2, and you get 7. All right, here in this equation, we have an absolute value sign that is not just around the variable. So when you have an equation that looks like this, where the majority of the equation is in an absolute value sign, when the rule part is in, we are actually going to write an equation for 2 different possibilities, because this part in here, this answer could be positive or it could be negative. So over here, this is where I would take my notes. It does tell us that when solving an absolute value equation in this format right here, where the majority of your equation, your ax plus b, is in absolute value symbols, you're going to use 2 different equations to find the solutions, okay? You're going to use ax plus b equals positive c and ax plus b equals negative c. So coming back over here to the problem in our example, you'll see here we are writing and solving the equations for both possibilities, okay? On the left, we have a positive possibility with a positive 1 solution, and on the right, we have a negative possibility with a negative 1 solution. When I solve, I'm just going to solve it normal, right? So I'm going to go ahead and add 3 to both sides, doing the inverse operation. I am then going to divide each side by 2 by doing the opposite of multiplication. And one possible solution would be positive 2, okay? Over here on this side, I'm going to do the same thing, but with my negative 1. So if I add 3 to both sides to negative 1, I get a positive 2. And if I divide by 2, I get a positive 1. So both 2 and 1 are solutions to this equation. And just like the last problem, you could plug both of these solutions into this equation and solve to just double check and make sure you're right. All right, here we have a third type of equation. So this doesn't have just my variable in an absolute value sign, and it doesn't have my entire rule of my equation in an absolute value sign. My absolute value sign is just embedded in the middle. So what we're going to do is step 1, remember when you see these steps, write them down for notes, isolate the absolute value expression. So treat the whole absolute value sign kind of like you would a variable and get it alone. So I'm going to get rid of that plus 8. I'm going to get rid of that times 3. And you're going to end up with an equation that kind of looks like what we just saw on our previous slide. If this was a positive 1 on this side, then we would split it into those 2 possibilities and solve. But because absolute value, okay, can never be negative because it is a distance, we cannot solve this problem. It has no solution. So again, write this down in your notes. Okay, when you have your equation equaling a negative, it has no solution because absolute value of a number is a distance and it cannot be negative. Whoops. All right, go ahead and practice each of these types of equations that we just saw on our previous pages. You have one where it's just your variable and your absolute value symbol. You have one that is embedded in the equation, and you have one that is just part of the rule. Take a look back at your notes, take a look back at the video, and see if you can solve these 3 questions. All right, we are now in the part of our lesson where we're going to do a real world situation. So we're going to take a look here at Kennedy's cruising speed. So she's got a boat that's cruising at 25 miles per hour. She plans to cruise at this speed for the distance shown in the diagram. So this diagram is telling me that Kennedy is planning on traveling 80 miles an hour, or a total of 80 miles, give or take 10. Meaning she could travel 70, she could travel 90. She's going to travel somewhere around here. Okay, so this equation is going to represent the number of hours that she's traveling. So 25 times x is her speed, and x would be the hours. Take away the 80 miles. This would be the final distance point from the 80-mile point, okay? And that's going to equal the 10 miles from the 80-mile point. So 10 miles either this direction to the right or 10 miles to the left. 10 miles positive or 10 miles negative. That's why we're using the absolute value sign, because it could be positive or negative 10. We are then going to take a look at Kennedy's cruising speed here, still 25 miles per hour, but we want to know the minimum number. So again, she plans to cruise at a speed for 80 miles plus or minus 10. We want to know the minimum number and maximum number of hours that Kennedy will travel. So if she travels that minus 10, that's 70, what's she going to do versus the 90? So we're going to write the 2 equations just like we did in the previous examples. If it's positive, here's our equation. If it's negative, here's our equation. We're going to solve each of these equations, isolating for x. And that tells me that our solutions is 3.6 or 2.8. So Kennedy is either going to travel at least 2.8 hours or at most 3.6 hours. All right, so now it's your turn. And the good news is that our equation is basically going to be the same. Kennedy is still cruising in her boat, and she's choosing to cruise at a speed for 80 miles plus or minus 10. The only thing that's changed is 20 miles per hour. So replace the 25 with 20 and give me the minimum and maximum time that she would travel now. All right, don't forget those absolute values can also be used in inequalities. So what we're going to do right now is find the solution of this absolute value inequality. So this means that the absolute value of x is going to be less than 3. Okay, so remember, because the absolute value of x could be positive or negative, we actually have 2 different answer options for the extremes in my solution. Okay, if I graph it here, my answer could be -3, not equal to, but greater than -3. Or it could be less than +3. not equal to. It could be anywhere between. So because the distance between x and 0 must be less than 3, the values 3 to the right and 3 to the left are not solutions, but everything between is. So this absolute value sign is saying that anything that is a distance less than 3 is our solution. We could write that as two separate inequalities here. So they did a kind of a goof up on here. There is a little typo. You could write your two inequalities as x is less than 3 and x is greater than negative 3. Or you can combine them, like we learned in our compound inequalities, to say that negative 3 is less than x, which is less than 3. Okay, both of these would be considered proper answers on a test, but this one is more compact and a little bit more efficient. All right, one more thing I want you to pay attention to right here. So here's a common error. It says, remember to look at the greater than and less than symbols when solving absolute value inequalities. Inequalities with absolute value have to be set up differently to solve if it's an and situation versus an or situation. So here is an example of that or situation. Because this absolute value of x is greater than 3, that means that it has to be greater than the distance of 3, so it's going in opposite directions. Okay, if it's less than, you're going towards each other, they can be included, but if it's greater than, we're going in opposite directions, so they can't be included together. It has to be an or. All right, so go ahead and solve this absolute value inequality and make sure you graph it on a number line. So you can draw your own number line or you can go on Desmos and try one online. But remember to pay attention to this symbol right here to see if it's an and or an or. Don't forget this one as well. Last example here, we have another real-world situation. Members of the debate team are traveling to a tournament where they will stay in a hotel for 4 nights. The total cost for each member must be within $20 of $175. Which of the hotels can can they consider? Here are our hotel room costs that are per person per night. Hotel A is $40 per person per night, $45 and $50. First thing we have to do, and this is the thing that I know we struggle with sometimes, is we have to write the equation based on the situation. So in this case, we're writing an inequality, an absolute value inequality, okay? X is going to be the cost per night of the hotel room. We know that the total cost for each member must be within $20 of $175. And because they're staying 4 nights, we need to multiply the price per person per night by 4. So they're getting 4 times the cost, and it has to be within $20 of $175. So it could be $20 less or $20 more. That's why we're using the absolute value sign. Okay, so because of this, we're then going to say that it has to be less than or equal to a $20 difference. Then we're doing the same thing we did previously. We're going to find the maximum cost and the minimum cost just by plugging in, just solving our equations for x. So we solved here for x and solved here. What this means is that the cost of the hotel room can be between $38.75 per person per night and $48.75 per person per night inclusive. So therefore, they can choose Hotel A, that falls between those two numbers, or Hotel B. They cannot use Hotel C. All right, so here's where you get to try it on your own. So we have the same type of question. Members of a debate team are traveling. They are also staying for 4 nights in the hotel room. But this time, the total cost for each member must be within $20 of $200. See if you can write that absolute value inequality. And then check, could they afford Hotel D at $55 per night and explain why or why not. All right, you could pause on this screen. This is just a little overview of what we learned in this lesson.